Today, it says Skipsters will be able to solve multi-step rate problems using dimensional analysis. So we're going to have several types of multi-step problems. We're going to talk about some more of the different types of problems. At this point, really all we've talked about are scale problems, unit conversion problems, and basic rate problems. Remember that basic rate problems are rate problems that have one situation and one rate. So today we're going to see some things that look like basic rate problems, but they're going to have a little twist to them. So that's what we're going to be looking at today. All right. So looking at this first problem, it says to build a fence, Kevin needs 15 feet of lumber per foot of fence that he wants to build. To build the fence with 210 feet of lumber, how many yards long will the fence be? So I'm looking at this question. It says, how many yards long will the fence be? I'm going to write my answer sentence. The fence will be blank yards long. Being really careful with your units. Okay, a lot of you who don't read very carefully might look at this and might put the wrong units on your answer, which is going to become very important. So as we're looking back through the problem, I see one rate that's given to me here, 15 feet of lumber per foot of fence. So that's 15 feet lumber for 1 foot of fence. Or I could write that the other way around, 1 foot of fence for 15 feet of lumber. I'm also given a situation here, 210 feet of lumber. So looking at this, this looks like a basic rate problem. So we're going to start writing down our type of problem again, because we have enough problems here. We have one situation and one rate that's given to me, so I'm going to write down that this is a basic rate problem. Then we're going to start setting it up. We always start setting it up with our answer units. So we need blank yards of fence. And what I'm going to start doing here is I'm going to start looking for a way to match my yards of fence. Is there any information that I've written down already that is going to allow me to match my yards of fence? Kyrie? No, there's not. We've got something really close. What's the closest thing we have? Viviana? Yeah, we have feet of fence. Now, we know there's a relationship between feet and yards, right? This is where the twist comes in. Our units aren't quite matching up. So we've got to do something to match them up. So right now, I'm going to go ahead and put down this 1 foot of fence over 15 feet of lumber. But I need to know right now that I need to find a way to change this feet of fence to yards of fence. What's the relationship between feet of fence and yards of fence? Kevin? Not true. What's the relationship between feet of fence and yards of fence? Iron? Leslie, what do you think? Okay, she's on the right track. She's thinking 12 feet is 1 yard. She's trying to come up with a relationship. She's close. Leslie? 3 feet is 1 yard. So she's telling me that she can write this unit conversion rate. 3 feet of fence is the same thing as 1 yard of fence. Or the other way around, 1 yard of fence is 3 feet of fence. So now I do have something that I can get to match my yards up here. So which of these two do I want to use? Do I want to use the first one? Do I want to use the second one? Show me with your fingers. Do I want to use the first unit conversion or the second unit conversion rate that we wrote? Good, that's going to get my yards on top. Now we've also used this guy already, so when we plug this in, 1 yard of fence over 3 feet of fence, we're going to see that that gets our yards on top, which is perfect, because that's what we need left over is yards of fence, and it's going to cancel out feet of fence with feet of fence. Are we done though? No, what's the problem? We've still got, Jalen? Yeah, we still got feet of lumber. Good news is, what can we use to cancel out that feet of lumber? Brenda. Yeah, the 210 feet, our situation here. 210 feet of lumber. So now the feet of lumber cancels out with the feet of lumber. Now our units all line up. So this was almost a basic rate problem, but what did we have to do in the middle? Kevin. Perfect. Yep. So we had to convert units in the middle. So this is a basic rate problem with that sneaky unit conversion. So this type of problem is a basic rate with unit conversion. Okay, so we knew it was a basic rate because we were given one situation and one rate, but we had that sneaky, and this is what test makers love to do, and I promise you'll see one on the CST like this. They're going to throw one in there that's going to have that sneaky unit conversion that's going to go in the riddle. So it's a basic rate with the unit conversion. So we're going to multiply top times top times top. That's 210 over bottom times bottom is 45. So we get 210 divided by 45, and I'm going to save you the math because I want to save some time. I know that's 4.6 repeating yards of fence. Okay, questions about that problem? Judea.
If it's not square, how come you have to do that? I don't.
Because feet of fence is not yards of fence. So we had to throw in that unit conversion to fix this feet of fence. So it would be yards of fence. Okay, let's look at another one. This one says a biker cycles 20 miles in 45 minutes. How far can he cycle in 3 hours? Okay, so looking at the question here, it says how far can he cycle in 3 hours? We're looking at that. We're going to write our answer sentence. How far can he cycle in 3 hours? He can cycle blank. What are my units? Miles. So as we finish that, we see the situation there pretty easily. Situation is 3 hours. And we see our rate here. He can cycle 20 miles in 45 minutes. So our rate, 20 miles in 45 minutes. Or it takes him 45 minutes to cycle 20 miles. All right, so we see that we were given one rate and one situation. So this type of problem is at this point a basic rate problem because it has one rate and one situation. We're going to start setting it up, starting with the units of our answer. Miles. I want to go ahead and match my miles using one of the pieces of information that I already have. And that comes out really well. We've got this nice rate set up here. 20 miles over 45 minutes.
And turn 30, I mean, 3 hours into minutes.
So Judea is telling me she's looking at this. She's getting ready to put in 3 hours, and she's saying, Mr. Boots, that's not quite going to work. Rogelio.
What? 200.
On the right track. So I feel like I hear him saying he needs to convert minutes to hours. So we're going to do this just like we did in the other problem. We're going to come up with that rate. What's our rate for minutes and hours? Iron.
7 minutes.
60 minutes over 1 hour. Or we can write it as 1 hour over 60 minutes.
This is hard.
So all I really need to do here is I need to plug one of these two guys in that's going to get rid of these minutes and get rid of these hours. So which of these two am I going to plug in that's going to fix my hours and minutes problem? Show me with your fingers, number 1 or number 2? Which is going to fix my minutes and hours problems, number 1 or number 2? So I look at you showing me number 1, so I'm going to put that in, 60 minutes over 1 hour. I'm going to look at how my units cancel. Hours cancels out with hours, that's right, top and bottom. Minutes cancel out with minutes, top and bottom, no problem.
60 times 303.
Okay, multiply top times top times top, that gives me 3,600 over 45.
Do you have any eraser?
Once again, I'm going to save you the difficulty of going through this division because I want to save us some time. I'm going to tell you that 3,600 divided by 45 is 80.
I got 7.
So, was this a basic rate problem? Yes. However, it was a basic rate problem that we had to do a unit conversion. So this is a basic rate with a unit conversion. Okay, those unit conversions, they love to throw those in there. And you're going to notice those as you set up your problem because you're going to say, whoa, I'm really close with my units, but they don't quite match up. All right? Questions about this problem?
Don't take the eraser out.
Kevin? That's what we did. Very good. All right. The unit rate for Purdue turkey breast luncheon meat is 50 cents per ounce. How much would 3.5 pounds cost? All right, so looking at this, again, looking at my answer sentence, how much would 3.5 pounds cost? It would cost blank dollars. So again, we're pretty obvious here. Our situation is 3.5 pounds. And we're given a rate here of 50 cents per ounce. Or $0.50 per 1 ounce. The other way around would be 1 ounce for $0.50. So again, looking at this problem, we have a single rate and we have a single situation, which means this is a basic rate. We're going to start setting it up, starting with the units of my answer. And I want to match that. Kip yes or Kip no, can I match that with the information that I have right now? Kip yes or Kip no, can I match that with the information that I have right now? Still waiting for 100%. Can I match that with what I have right now? Okay, should be showing me yes because we have this dollars on top, so we can put $0.50 on top just like we want to over 1 ounce. So here's where we would be ready to plug in our situation. So I put in 3.5 pounds and I cancel out my units. Leslie? So Leslie is saying, I can't cancel out pounds and ounces. This is where you get in the problem and you go, hey, this must be a basic rate with a unit conversion. So we need to figure out the conversion rate between pounds and ounces. So 1 pound is 16 ounces.
I knew it.
Or 16 ounces is 1 pound. Which of these two do I need to plug in to fix my units problem? Number 1 or number 2? Which one do I need to plug in to fix my units problem? Which one of these two is going to fix my units problem? Number 1 or number 2? So this is very common. So it's not unusual for us to say, hey, I want to plug in number 1. And 16 ounces. And I look at this and I go, wait, that put my pounds on top and my pounds on top. That's not right. Not a big deal. So all you have to do, erase, put the right one in. So we're going to put in the 16 ounces over the 1 pound. That gets my pounds with my pounds. Gets my ounces with my ounces. And we get 16 times 0.5 times 3.5. I'm going to save you again the math and the time. I'll tell you that 16 times 3.5 times 0.5 is 28. Questions about that problem?